All right, my math 3. Sorry I can't be there on Friday afternoon. I had to make a doctor's appointment, and I really needed to keep it for this Friday. So I had to step out after I was in school in the morning. So I am available for if you send me emails and stuff. I'll get to them when I'm all wrapped up later on that afternoon or maybe the next day. Anyway, what I need you guys to do is to finish off the notes that we had already started. So on page 3 of the note packet, the sub will have available extra set of notes in case somebody wasn't here or you forgot your notes or something like that. Where we left off was, hey, if we have in a circle, if we have congruent chords, that means we're going to have congruent arcs that are cut off. And if we have congruent arcs, that's going to lead to the central angles if we draw them out. So it would look like, hey, these are congruent, that makes these arcs congruent, that makes these angles congruent. Remember, the arc degrees is equal to this central angle. That makes them equal to each other. There's going to be another rule, really right by the bottom of this page. There'll be another rule to go with that. Here we go. Put it to practice. Find the indicated arc measure. So we have to find xy. That's this arc right here. Xy is this arc sort of on the top left. These chords, it's very subtle, they marked them off as congruent. Well, this is a really easy one. If these are congruent, they have congruent arcs here and here. So if this is 105, then the measure, that's that cursive M, or italic M, the measure of XY is going to also equal 105 degrees. Not a whole lot to that one. Find the measure of arc TU. TU's on the far side. So this arc is what they're looking for. Notice that this chord is congruent to this chord. So if those two are congruent, and this central angle is 85, it's going to work out just like this one over here. Hey, if this central angle, because it goes to the center, if that's 85, then this arc is 85. That means on the other side, since congruent chords means congruent arcs, that's going to be 85 degrees as well. So there's a couple of examples. If it's central angles and congruent arcs, that makes it pretty darn easy. All right, now, we're not going to do Desmos, especially when I'm not there to walk you through it, but I don't usually do the Desmos stuff. I usually talk about it. Now, people get confused by the lettering, but alpha and beta, those are Greek letters of the alphabet. They just use that with angles. They use those instead of writing like, hey, find X and find Y. They say, hey, find alpha, this angle, and find beta, that angle here. What is the value of the alpha plus the beta? Well, there's no measurements on here, but you guys told me in class, what's the measure of a full circle? 360 degrees. Because it's 360 all the way around, to find these two angles, we could figure that out because this figure on the inside is what they call inscribed. Every corner is on the circle. So because every corner is on the circle, we say that, what is this, D, C, F, all right. We would say that D, C, F, E is what they call oh, I already misspelled it. Oh, I had it right the first time. Cyclic means all four corners are on the circle. All four corners are on the circle. All right, that's meaning it's cyclic, or you can say concyclic. It's a cyclic, or sometimes it's concyclic. Now, there's a rule, which really it should have been somewhere else in the notes, but there's going to be an important rule here. And inscribed angle measure is 1/2 of its intercepted arc. Now, that rule is going to help us answer this question over here. So, an inscribed angle's measure is 1/2 of its intercepted arc. So what does that mean? Well, you got to remember what an inscribed angle looks like. So if you have a cycle, if I draw a vertex to the center like this, that's a central angle. But if I draw one that's off to the side like this, if the vertex is on the circle, this is the vertex. If it's on the circle and it cuts back 2 chords, then this is the intercepted arc. All right, it's caught in the mouth of the gator, like a gator that opens its mouth. This is caught in between. So how do you find that measurement here? Let's call it angle B for Butterfield. All right, call this A, call this C. The measure of angle B is equal to 1/2 of whatever that arc is. 1/2 of whatever the arc is. So as an example, if I wrote arc AC, let's see, it's a little bit more than, I'd say that's more than 90. So let's say that's 100 degrees. If I know that's 100, and I say, well then angle B, if the measure of AC equals 100, then the measure of angle B is half of that, 50. Sometimes they give you the angle, like if I give you that's 50, you double it, that's 100. If I give you that's 100, then you cut it in half. So if like that was 130, then I cut 130 in half, and the angle B would be 65. Now, getting back to the original question, because these are inscribed angles, alpha is half of this arc. From here all the way to here. It's a pretty wide angle, so it's a really big arc. And beta, this angle, that would be half of this arc. Well, if you notice in tracing it, I just traced the entire circle. So I don't know how much is each one. I don't know what the degrees is here in degree. I'd have to know a number, but I know what the total is. That's 360, and if I take half, then alpha plus beta would equal 1/2 of 360. So those two are going to be alpha plus beta will automatically equal 180 degrees. Now, the trick is you never figure out how much is alpha and how much is beta, but you know that added together, they got to be half of the entire circle. This leads to a rule, all right? Let's see if it's on the next page. Oh, they leave me room to do it on the next page, but for any quadrilateral, 4-sided figure, the opposite corners will add up to be 180 degrees. So angle D plus angle F also equals 180 degrees. My light on? Oh, that might help it a little. That'll also equal 180 degrees. Take a moment, catch that up. What I'm going to do is turn it over, and I'm going to summarize the rules that you need to know in order to be successful. Now you got to know all the little definitions of the different names. What's a diameter? What's a radius? What's an arc? What's a minor arc, major arc, semicircle, that kind of stuff. That's all part of it. But for calculations, keep in mind that, I was going to write the word out, but remember that congruent is this symbol. All right, so I'm going to say congruent chords will mean that we'll get congruent arcs, which will mean we'll get congruent central angles. And if any one of those happen, all of them happen. So you can start with congruent arcs and then the other two happen. Or you can start with central angles, then the other two will happen. So congruent chords, do it like this. That would look like that. That would give us congruent arcs. So if I draw the same diagram, and down here, that would give us the arcs they cut off, the ones they slice off. Those would be congruent. Now the central angles, this gets a little crowded. If I have this, all right, the central angles, I would draw the radii in. So from the center to each corner. So I go here to here, that makes a central angle. and that would be congruent to here, here. Those two angles are central angles. Those are congruent right there in the middle. They're not vertical. They're close to vertical, but they're not vertical. Okay, that rule isn't as important for calculating stuff as these two different ones. For any central angle, its measurement equals its intercepted arc. All right, that arc is the one that's caught in the mouth of the gator. So if you have a circle like this, and I draw a central angle, all right, this would equal whatever number goes here. So if I put 85 degrees, then x equals 85 degrees. Whatever this arc is that it catches in the mouth of the gator. Okay? Now that only works for central angles. That's the easiest of the rules. Now inscribed angles is like the next step up in difficulty. Not difficult, but it's the next step up in difficulty. For inscribed angles, now when they're inscribed, they're no longer drawing the vertex to the center. Central has a vertex at the center. Inscribed has a vertex anywhere on the circle. So what do I mean by that? Draw this. You can have a skinny inscribed angle. You can have a really wide inscribed angle. Let me make this one wide, like this. So if I ask you what is this, you need this arc from this point all the way down here. So like as a gator with the mouth that's really wide, you're going to take half of that number. So let's see, let's say that's 120 degrees. So x would equal half of that. That would be 60 degrees. Now that's going to be the really important part to do the next part of this lesson. You got to look for things as you're doing these kind of problems. We're going to do a little practice on the next page. A lot of these will draw a circle, and you know it's 360, but then they'll draw a diameter somewhere in the picture. And they might have all this other, they might have a central angle here and an inscribed angle here. So this one equals this arc. This one is half of this arc, but they're going to make you work to find all the arc numbers. They total 360, but this diameter cuts it in half. So from here to here, you know on your own that's 180. And from here to here, you know on your own that has to be 180. Now knowing that, that's going to help you fill in all the other stuff. All right, let's do the practice on the next page. Practice. Talk about practice. All right, look at that. It's the exact same one we did in class the other day. I noticed that number. It's still hanging on my wall behind me. That's 20 degrees. That's this little angle in here. That's 20. That's a central angle. So x is equal to 20 degrees. And then I remember you guys in class, you guys figured this out pretty quick. Going across, that's a diameter. So from this point all the way to this point, that arc would be 180 degrees. So that's 180. So if this part's 20, then that means y would be 180 minus that 20. And that would be 160 degrees for y. And then z is a very wide to the center. That's a central angle. So a central angle would be equal 160 degrees. It's kind of a repeat. All right, number 2, give an example from the image of each kind of segment. Take a moment. It's pretty easy, or pause it, try it yourself. For diameter, you got 2 possible answers. You can call it BC, and hopefully you see this. There's another diameter in there. You would say GH. No arrows on top. BC or GH. Okay? Name a chord that is not a diameter. If I put arrows on GH, by the way, if I put arrows on it, that's not true. I know it goes off the page here. Looks like it goes forever. So maybe whoever typed it up, maybe they only meant BC, but you can call GH a diameter as long as you put endpoints. Stop at G, stop at H. All right, a chord that's not a diameter, there is only one choice. Take a moment, take a look at it. There's only one chord that's not a diameter. Those are endpoints on the circle, but it doesn't go through the center because it's not a diameter. That's going to be DE. That is a chord of the circle. A radius, boy, you got a bunch of them in here. I see 4 different radii on here. A radius would be like AB, boom, or AG, or AH, or AC. Again, no arrows on it, just endpoints. All right, always, sometimes, never true. A diameter is a chord. So look at BC or look at G to H. Their endpoints are on the circle. That one is always. A radius is a chord? Never. A radius only goes halfway across. A chord has to go all the way across to the other side. So that's why it's never. A chord is a diameter. Well, there's 3 chords in here, but only 2 of them are diameter, so that's a sometimes. Right? Just because it's a chord, like DE is a chord, but that's not a diameter. It has to go through the center. You get a chord that goes through the center. That's a diameter. Can a central angle be 90 degrees? Yeah, sure. Sometimes. Not all the time. Sometimes. If it happens to go straight to the middle, straight over, straight down, straight over, that would be a right angle. So it could happen. So that's 90. The arc would be 90. But does that happen all the time? No. No, definitely not. All right, find the measure of arc AB. So they gave us this angle here. What I would do is trace it, and you will see, oh, it's an inscribed angle, and it intercepts this arc. So if that's 40, I double it, that part's 80. 40 to 80. But they want to find this one. How do I find that arc? So you have to find this one first, then recognize, oh, that little dot, that's the center right there. That means this is 180. That means the top part's 180. And you would say the measure of AB is going to be 100 degrees. 100. You do 180 minus 80, or you do 360 minus all the other arcs to get the last arc. All right, this one. This angle they give us, BOA, all right, or AOB is how they put it, that's 56 degrees. So right away, that's a central angle. Those are the best. Those will make it easy. So that's 56. That means this is 56 degrees. All right, they just made it really easy for me. Now, that's not what they wanted for a final answer. What they want you to find is, what's the measure of angle ACB? ACB, this angle all the way over here. That's an inscribed angle. But if you trace the sides of it, goes to here, goes to here, this is the intercepted arc. So angle ACB is equal to 1/2 of arc. I lost my letters in there. I can't even see it. I think that's B. That's A. Half of arc AB. So it's 1/2 of 56, angle ACB. Quick math, 28 degrees. 28 degrees. This is geometry, and this feels good. This is Soikos. Oh, I missed teaching geometry. All right, back on track. Arc BA. This tiny little arc over here is 30. Ooh, it's tiny. There are no diameters in here. There are a couple radii. But D is an inscribed angle, and C is an inscribed angle, and they both, if you trace them all the way across, they both intercept 30. So these two angles are going to end up the same. They're going to be half of 30. All right, what angles do they want? They want BOA first, B-O-A. Well, that angle's easy. That angle is a central angle because it goes to the center O. that's going to be, so if I isolate it, it would just look like this. Well, that's 30, so that's 30. I mean, it's as easy as that. But angle BDA is this angle here. That's BDA, half of the intercepted arc. So take 30, cut in half, 15. And BCA is the other inscribed angle. So since they intercept the same arc, they're half of the same number. Take half of 30, and you get 15 degrees for the other one. I'm liking this. Okay, now, quadrilateral. Now, this only works if it's a quadrilateral, which means it's got 4 sides. If it's cyclic, that means a circle can be drawn around all those points. So there's a circle. Maybe I can get it. There's a circle that goes around all of the corners. Kind of misses down here, but that's hard to draw freehand. Now the rule is opposite angles. That's back on this page. One more page. The opposite angles add up to be 180 degrees. The opposite corners add up to be 180 degrees. I probably should have added that to my summary here. What's the measure of angle C? Well, angle C plus angle A will equal 180, half a circle. Those two opposite angles will be half a circle if you add them together. So A is 135. If I do 180 minus 135, angle C, 180 minus 135, that's going to equal 45 degrees. Now for angle B, now you got to go all the way across, so you can't count A. You got to go all the way across. It's not exact, doesn't look opposite. That's because it's so goofy of a shape. But B and D are across from each other. Angle B and angle D will also add up to be 180. So if you know one of them, B is 75. 180 minus 75. Angle D is going to equal 105 degrees. 105 degrees for that one. All right, and number 8, determine arc EFG is from here all the way to here is 140. Now it would be a mistake to go, all right, that's 70 and 70. We don't know that. You know, it could be like 100 plus 40. It could be 80 and 60 for the two arcs. So don't assume it's 70 and 70. That would be a mistake. It could be, but don't assume that. Now this is 65. That kind of helps. If that's 65, then E, I'm going to do this one right away. Based on what we just did, angle G plus angle E has to add up to be 180 degrees. So if G is 65, subtract 65, you get 115 for E. Opposite corners add up to be 180. Well, I want to do opposite corners again, but we're missing the two angles here. So here's what we got to do. If this is 140, I'm going to trace it for you. This is an inscribed angle I just traced in green. Angle B is an inscribed angle. Its vertex is on the circle. It cuts off this arc all the way from here to here. So if this arc is 140, then how do we find angle B, inscribed angle? It's not essential, so it doesn't equal 140. You take 140, cut it in half, and angle B, oh, it's not actually not even an option. That equals 70. We're just going to add it to the diagram. But that helps me find angle F. Angle F, no, it says H. Oh, that's because I'm looking at this wrong. That's not B, that's H. Dum. That goes here. That's what happens when I don't wear my glasses. That's 70 degrees. Now it makes a little more sense. But that can help me find this arc. Or, I'm sorry, not arc, but that angle, 70. That has to be 110. They're not asking me that, though. They want arc FGH. Here's F. G to H. Oh, we could do that. So to get this one, F through G, all the way to H. How do I get that one? I'm going to use the inscribed angle going this way, really wide one. Now remember, a full circle is 360 degrees, and this arc is going to be twice as big as this inscribed angle. Like if you know this arc, you take half and you get 115. If I have the 115, to get this arc, I'm going to have to double that 115. So 2 times 115 gives me 230 degrees. It's a big chunk of the circle. Remember, all the way around is 360. So don't be nervous because it went over 180. You get 230 degrees for that one. The only thing I would say is on the summary on the previous page, quadrilateral, that is cyclic. So it's got to have 4 sides, and all 4 sides touch, all 4 corners, they say, touch the circle. Call it A, B, C, D. Then angle B plus angle D is 180. Angle A plus angle C equals 180. Now your notes are really full. All right, now that's the end of the notes. There's a short worksheet, not much to it. There's a short worksheet to fill it out. A lot of like naming the different parts, different kind of arcs. You got to use your notes, even the ones from the previous one. All central angles here. That makes it pretty easy to find all the arcs. You got a couple of diameters to help you out as well. On this page, there's 1 diameter, so there's some directions. You put them in. There's a bunch of arcs and angles to find. Just remember, as you're doing this, inscribed angles. Oh, that's not inscribed. Inscribed the other way. RMN, that's half of that arc. Then you have some central angles. You can also use 3 angles of a triangle. They add up to be 180. That rule still applies. So that angle, that angle, that angle, they add up to be 180. But you got all these arcs and all these angles to fill in. All right, and then you got some short ones. So central angles. Looks like inscribed angles and congruent chords. So those arcs would be congruent. Inscribed, central angle, and then you got your concyclic problem down here about the opposite angles for that kind of problem. This one, it's not real clear, but these are marked as parallel. There's like an arrow. Those are marked as parallel lines, so use alternate interior angles. But that'll be the homework assignment. I'm going to leave it the sub also. You should have seen your scores online from your chapter test. If you want to do a retake, you got a form to fill out. What pods do you want to retake? And then you needed a checklist filled out. Do you have notes for all the sections? Do you have homework assignments turned in for all the sections? So even before we meet and go over it, we will go over it. You want to look at it and say like, oh, I have homework to make up, or I got notes that I need to have filled in. I got to have all that stuff ready if you want to do that. I'll be in contact for those that are going to be signed up to the Mrs. Rosani as the MTSS Tier 2 tutoring. But the only way you get into that is if you've been doing homework assignments all along. If you're a kid that hasn't done any work, you have a lot of stuff to make up, you do have options for a retake. You have to come see me during office hours or see the regular drop-in tutor to make up your stuff and prepare yourself for the test. And there'll be 2 weeks after the day I go over it. So I'm not going to count it from this day. I'm going to count it from the day we go over it together the next time we meet in class, which I'm expected to be there the next class. This is just for a doctor's appointment that I missed today. If you have any questions, please email me and I will get back to you over the weekend. Have a great weekend, everybody. And please behave for the sub.